in this example with the virtual environment, we are going to use the virtual environment that you created in the session for isolated environments. The one here just before. Okay, and I have this environment created on each of the centers, and it's VPI env, as we talked about there. I'm just going to change again in to this directory here and show it's here also. And in that virtual environment, you install the Seaborn package. Okay, so let us try and run this example here. And I just want to say a little bit about this because just like before, this is much the same as for the serial example. You load the module Python. And then is the important difference. Here you source the virtual environment that you activate the virtual environment by sourcing the /bin/activate file under the virtual environment. So when you go into this code and let's see here, it is, let's see if I can find it here. Serial Python virt, and then Cosmos, Kebnekaise, and Rackham. So I will open this one here. And you can see here it loads the same modules that you loaded before when you created the virtual environment. And I have changed this line here so that it just is the path to my virtual environment. Because I have the virtual environment in the same directory here, I created it just under this Python exercises directory. Because of that, this is my path. But if you have put it some other place, for instance, outside of the exercise directory, you would have to give the full path to it. So it would, for instance, be /project/no-backup/ your username, then if you had created it directly in that directory on your storage directory on UPPMAX or on Kebnekaise. So on Rackham, you probably have it in your home directory. Anyway, the source, you source the path into the virtual environment /bin/activate, and this is where I have it located. So, and I have changed it on each of the centers. Other than that, you just run the script, and it is this Python script here. And there is a minor difference, which is that you need to I'm loading an example dataset remotely from a repo that only works at HPC2N and LUNARC. So at UPPMAX, I have changed this a little bit. So this would be how it looks there, and this is, so there will be two differences, and you can find them here. See, let's see. This is the code for Rackham and the code for Kebnekaise. So there's just a minor difference in how you load this data file tips.scv. And you can see here it creates a plot, and because we're running a batch job, the plot will not be shown directly. Just like you cannot interact with the batch job, you also will not get things like created plots shown. They will not just pop up, so you need to save them, and that's what I'm doing here. So I'm saving it to a file called tipsplot.png, and that will show up here. I already ran this, so that's why. But I'm going to run this code here. So I'm taking this one here and submitting it. And oops. No, I don't want to save modified buffer. And I'm also submitting this here. And now I can do SQ minus ME and see that it is running. And just like before, this can have different states. It can be pending, running, completing. I think I'm just going to submit this several times so that hopefully there will be time to see this. You see here, it runs a lot of time. Yeah, and now these are completing, so that is good. And then in your directory, you will get a lot of Slurm output files. And as before, it's called slurm minus the job ID.out. That is a file the output will get into unless you change it directly. And there is an example of that in this directory here also, where, and I'm going to talk about it, but it is possible to put the output and the error files into different files, and you can rename the output file as well. But as default, it will just be slurm minus the job ID.out. And the job ID, to repeat, you get it when you submit it with sbatch, and you can also see it with SQ minus me. Okay. So since it ran, let's see what happened here. And in this case, these output files, I just want to show it. They contain very little, and the reason for that is that in this case, we actually have the output created here as a tipsplot.png. If I had opened this shell here as a GUI or with X11 forwarding or something, I could open and show you this PNG file here, but I cannot do that right now. But you will be able to do that yourself when you are running this job. And let's also submit it down here. Serial Python Cosmos. Okay. So this is an example I would like you to try and run as well. Of course, if you have created this virtual environment before here on the isolated environments, otherwise you will have to do that first. Okay, so let us go to the next example, which is a GPU code. And while I say here I'm not going to test it live, I'm actually going to test it live. But since you have Snowy access on UPPMAX, and since you have access to the GPUs on Kebnekaise and Cosmos, then you can actually run it now. And there is actually some issue with PyTorch on the machine learning package on UPPMAX. So originally, you would have to use a virtual environment, but I found that if you are using this version 3.11.8 instead of 3.9.5 as we did before, it actually has this machine learning package and it's installed correctly, so it will work. And this is just a short example for running it on Snowy, and you should be able to try that as well. So you can find this code in the directory here. And if you say ls star snowy star, that means it will list all files that has snowy in its name. And you can see here that these are all shell scripts, batch scripts, sorry, that can be run on Snowy. And this one is the PyTorch fitting GPU. And there is a shell script here, batch script. I'm going to open it. Let's do that. And you can see that it's this one here. And the thing to pay attention to when you're using GPUs is that you need to ask for the GPUs as well, of course. And there is an important difference here between UPPMAX, HPC2N, and LUNARC. The main difference to UPPMAX is that here the machine that you are logged into, Rackham, does not have GPUs, and that means it has to be run on Snowy. And to run on Snowy, you can submit the job from Rackham and saying hashtag sbatch minus capital M Snowy. That means that the batch job will start running on Snowy instead. And Snowy does have GPUs, and you are asking for GPUs with this command here, minus minus gres equals GPU, and you can ask for one of them. Also pay attention that you need, in this case, a Python _ml_ packages, and for the same version of Python 3.11.8, and you want the GPU version of them. That will only work on Snowy. If you're using this module on Rackham, it will be CPU at the end instead. But now we are running on Snowy. So I will submit this here. Dispatch, PyTorch, and Snowy. And meanwhile, I will also go and talk about it on HPC2N. Because on HPC2N, the difference there is that HPC2N has a lot of different GPUs. And so you need to ask for how many GPUs, and you do that with minus minus GPUs equals 1 up to the number of GPUs are on that specific type of GPU node. And there are several, and I will go into that in this section here about GPUs in a little moment. But in this case, we are using an A100. And that we do by this constraint here, where we say minus capital C and A100. So this is how you ask for one GPU on A100 on Kebnekaise. And then we load suitable modules. And inside this PyTorch module, which is GPU enabled, as you can see with the CUDA here, it loads the correct Python as well. So I will also submit this here. Like this. And then finally on Snowy, again, you have two lines that you need to give in order to ask for a GPU. And here you have a specific partition that you need to add to use the GPU A100. And then also you tell how many you want of these, and you do that this way. There are also, like on HPC2N, you need to load these modules here, and it's the same ones as on HPC2N, and in the same case here, Python is included in the PyTorch. I'm also going to submit it down here on Cosmos, like this. And I needed to make a change to that one. That is correct. And I forgot to add that. You have to give a number of tasks per node. And I'm just having one here. So pay attention to that. When you are running on Cosmos, you need to add minus minus n tasks per node equals 1 for it to work. And I will get that changed in the material as well. Yes, I'm saving this. And now it submits it, as you can see. And probably it has run on all the centers. It has, yes. Okay, good. So aside from those, there is also an extra exercise here where you can try and run the serial example script that was up here, this one, see? Try to adjust that to run add list. And it should be fairly simple to do that, but there is one thing to pay attention to. In order to get the, sorry, it's called sum2args, of course. Get the serial Python batch script example to run this one instead. So this make a script like this that runs this example down here. And one thing to pay attention to is it needs 2 arguments. So there is something you need to change in the batch script, aside from just adding sum2args instead. You also need to make sure it takes the 2 arguments. And you have the solutions here you can look at. But try and see if you can solve it yourself first. So the key points here was the Slurm scheduler handles the allocations to the computation or calculation nodes. The batch job runs without interaction with the user. A batch script consists of a part with Slurm parameters describing the allocation and a second part describing the actual work within the job, for instance, one or several Python scripts. And pay attention, you need to include possible input arguments to the Python script in the batch script, since you cannot interact with it. Okay, I would suggest that we take 10 minutes and that you try and run first, submit this and see that it runs, look at the output in the slurm-jobid.out file. You can look at it with nano, as I did, or you can use the command less on the file, slurm, and then whatever job ID you get, .out, and then it will output the content to the screen. And you submit it with sbatch, so try run this. And if you created the virtual environment, isolated environment in that section, you can also run this example here. There's one for each of the centers. It is located in the exercises /Python directory that you got when you fetched the tarball and untarred it, or if you did git clone on it, on the file. So there's this example here, and then there's also the GPU code that you should also be able to run. And I will make this change here where it needs -n tasks per node added. Finally, then is this file here that you actually have to make some changes to our batch script also and see how it runs. And if nothing else, try to run the example directly with one of the solutions.